Welcome and hello. This is a video exercise in MODSIM, and in this exercise, we're going to be dealing with conditional storage targets. So in exercise 9, we dealt with how conditional rules can be used to control reservoir priorities. In this exercise, exercise 10, we're going to see how conditional rules or hydraulic states can be used to control storage targets in reservoirs. All right, so what I have on the screen here is my MODSIM. I'm going to start from the very beginning and begin by sketching in my network. Let's go ahead and start with a couple nodes. So here is a non-storage node. I'm going to add a reservoir downstream of that. After that, a consumptive demand node, an flow-through demand node. Move that there. And then let's see, how about one more non-storage node, and finally a network sink. Okay, so I'm going to go ahead and label these as well as give them connections. In fact, let me go ahead and save this before I forget. I'm going to go File, Save. Here's my project directory. I'm just going to call this exercise 10. Okay, there we go. Save. Okay, so non-storage node 1, I'll just call it NS1 and then move the label off to the side. Reservoir, I'm going to call this Res1. The demand, I'll call that D1. The flow-through node, I'll call this D2, even though it's a non-consumptive node. NS2. And then I'll leave the sink just as a label called sink. All right, so let's see here. Now to connect these elements, I'm going to connect them in the same order that I sketched them out. So D1 to D2. When you're adding a link, you just go ahead and make sure your cursor has the clicky hand icon, not the mouse arrow. Once you get the clicky hand icon right there, go ahead and drag to the downstream link or the downstream node, and that connection has been made. Okay, it kind of snaps into place. So it's a very easy to use user interface. All right, so let's get started here with our data entry. First thing I want to do is set the time duration of our simulation. This is going to be a 5-year simulation. I'm going to be using real world reservoir inflow and real world storage targets. So we're going to see what that looks like as well. So I'm going to go up to MODSIM, Network Settings. And let's move this over here. The time step tab is what I want to select. We're going to be using a 1-month time step, so that's already good to go. But down here in the data end date and simulation end date, I want to change that as well as the start dates. So this is going to be from 2020 through 2024. So the first 4 years of that decade. I'm going to click on the year and then just type in 2020. And then for the end date data, I'll click the year and type in 2025. Oops, 2025. There we go. And then for the simulation start date and simulation end date, it looks like the simulation start date already initialized to what I want it to be. So the end date, this is a drop down. I'm just going to select the last record, and that should be the same date as the data end date. Okay. So I have 5 years of time duration for my simulation, and that is 60 time periods in the table down below. We're good there. I don't need to do anything else here. I'll click Apply and then click OK. Next, I want to populate the inflow. So we'll start from the top and then work our way down as we add data to this network diagram. I'm going to click on the non-storage node 1. This is going to be serving as our reservoir inflow. Click on the Open Properties button. Okay, that opened up. What I want to do is type in data or paste in data in this flow rate column, and then that will be the amount of flow rate in acre feet per month. I'll just leave those units as it is. And then I'm going to change the start date and basically have a new record every month. Okay, so that's what it is by default. It also is not varied by year by default. So I'm going to click the checkbox here, click OK. That means I'm going to have different inflow data for each of my 5 years. And that is what I want. Okay, now you may have data already. You may synthesize data or create your own. But for this exercise, I'm going to use data that really exists, actual historical data. So here in California, we oftentimes use the CDEC data. I'll leave a link to this CDEC webpage in the description of the video if you're curious to use data here. If not, not a problem. But if you just want some dummy data, this is a good place to come to. I'm going to scroll down here and click on CDEC Station Search. Now, I already know the station ID that I'm going to be using, but I wanted to demonstrate how the station search works as well, so you can quickly find a station that has the data you want. I'm going to scroll down here and I'm going to click on sensor type. I'm going to check the checkbox. This is the type of data. So we have all different types of data in this dropdown. The one I'm looking for is inflow. So this is alphabetical. And here's what I want, inflow. There's also this inflow V. I'm not sure what that is, but let's go with inflow. And then 2 rows down for duration, I'm going to check that. I've clicked on monthly because I really want monthly inflow, but we don't have any monthly inflow. You can even click on the search for CDEC stations just based on those 2 parameters, and it gives you no results right here, unfortunately. So I'm going to go back in my browser, change data from monthly to daily, and then go ahead and click search. We're just going to have to convert daily data to monthly data. And then here are the results. So on the far left, we have the station ID and then the station name, the river basin name, and the location. It looks like it's alphabetical, so you can go ahead and choose whichever dam location you have. And these are all dam location sites, I believe, because we used inflow, reservoir inflow, for the data that we want. Okay, I clicked number 2. This is the second page of results here, and the data that I'm going to go for here is Folsom Lake. So FOL is all I need. You can click on this FOL and get more data that is very specific about that sensor. All I need to know is FOL is the station ID. So I can come back to the CDEC webpage. This is the home page here. And then this time, instead of clicking on CDEC station search, I'm going to click on historical data. Okay, so that opened up a historical data selector page. Here are the critical form fields I need to provide. So I'm just going to type in FOL, wait for the auto suggest to pop up, click on that record, boom. And now down here for the sensor number, this is the type of data. This is going to be inflow. Okay, here's the drop down. Here's my different options. And I believe 76 was what I'm looking for. Yep. So here's 76. It says reservoir inflow and daily and hourly. Hourly is way too far discretized for what I need. I'm doing a monthly timestamp. So let's just go with daily. Click on that record. Now I need to provide the date range here. So I'm going to go from the beginning of the year 2020 to the end of year 2024. So there's 5 years of data. Then click on view data. It's going to open up a new browser tab and with the data that you requested, if it exists, and it looks like it does here. So these are records in daily average inflow in units of CFS. And then again, it ranges from the very beginning of the requested time period to the very end. So I scroll down to the bottom of the page here. Here is the last record in that date range. And I'm going to click this Excel button to export that data to Excel. I have an Excel file that just downloaded to my desktop. That's good to go. But there are a few other export options down here, like copying to your clipboard, export to a CSV file, print, and PDF. Okay, so let's see what we got here in this Excel file. I'm going to go ahead and just open that up. Then here is that data on my screen. Not too surprising, it's just the date and the same inflow values that we saw on the web page. All right, so what I'm going to do is copy this data onto my clipboard, Control C. I'm not going to clean it up. I know there are some missing records right here, and I probably should do some sort of correction, but I think there's only a couple records like that anyway, so it's not going to be a huge difference. Next, I'm going to come over here to an Excel file I have prepared and then paste in those values. So what I pasted in here was columns 1 and 2. And then in some of the rows over here, further to the right, I've got the month, the year. That's just parsed from this first column here. And then in this table, that's columns 8 through 11, what I have is 1 row for every month. So up to this point, we had 1 row per day. Now we have 1 row per month. So we only have 60 rows in this table here for the 60 months of our simulation, summed up the flows in CFS, and then I've converted that to acre feet per month. So these are the actual values here in this column 11 that we're going to be using for our inflow at NS1, that non-storage node at the very top of our network that's going to be flowing into our reservoir Res1. Okay, so all that work was to get this time series data. I'm going to go ahead and copy it onto my clipboard. Then let's move the Excel out of the way. We don't need this anymore. Here is the inflow table. And then I'm just going to go ahead and right click, paste column. Now here are the values that I had on my clipboard that came from the CDEC webpage. Here are all 60 records. That looks good. And if I click on the plot right here, we can see that plot of inflow. Looks like the 4th year, which is 2023, had the most inflow. So that'll be fun to work with. Here is the bar plot. The previous plot there was the line plot. So we are good to go on our NS1. I'm going to click apply, click OK. And then now it's time to edit some reservoir properties. I'm going to go right click, open up the properties box. All right, I'm going to go ahead and add some data. Here in the general tab, I have selected the maximum volume of the reservoir will be 1 million acre feet. The units is acre feet, so that's specified right down here. The minimum I'll say is 0, even though in reality it's not 0. I'll just say it's 0 for this exercise. Initial volume, I'm going to say that is 400,000 acre feet. And that is all I need to do for this general tab for my reservoir. Keep note that I am going to leave the priority of the reservoir at 100, so that will come into play a little bit later. All right, the next tab over I want to define is the runoff forecasts. That's this tab right here. This will vary by year, so I'm going to check the checkbox here, click OK. And now what I'm going to do is just paste in the same data I had used for my inflows. Okay, so I've copied those same values onto my clipboard again. I'm going to come over here and right click on the flow rate title, the header of that column, and then paste columns. Okay, and it looks like the start date of that flow has automatically updated year after year. So it's good to see that the year is changing as well. Okay, I'm going to click on apply and click OK. Okay, just kidding. I need to actually do one more thing in my reservoir properties. I'm going to come over here to the targets tab. And then for the targets, what I'm going to do is use historical targets values for the Folsom Reservoir. We also have a record of that. Here's a separate reservoir page. And if I select the Folsom value right here, it shows me some historical Folsom Lake values. And then from this plot, this light blue background line is historical storage values over the course of the year. So using this data, I'm just going to approximate what is the volume based on the month. So for instance, here in January, is this January? No, it starts in October, I guess. That'll be a value of about 450,000 acre feet. Down here in December will be a minimum of closer to 400,000 acre feet, and then a maximum will occur around June 1st. That's around 750,000 acre feet. So let's move that out of the way. Those values I'm going to paste in right here. So I'm going to just right click and paste column. And then if I click on the plot, we see the target volume in that reservoir sort of cycles between 400,000 and 750,000 for the 5 years of our simulation. And that's all I need to do with my reservoir. Okay, so for real this time, I'm going to click apply and OK. The next downstream element in our network is this link right here, res1 to node D1. I'm going to go right click and convert to multi-link. The reason I'm doing that is because I want to have an actual link for the normal flow, but then I want to create a separate link with a high cost that's associated with the reservoir spill. We don't want to spill water from our reservoir, but it's better than having an infeasible solution in the event we have a ton of runoff or inflow to the reservoir from NS1 at any particular month. All right, so by default, we have our one link right here. I'm going to go ahead and select that link and then click on edit. The only thing I need to do for this link is actually first I'm going to rename it. I'm just going to say dash main. By the way, if you do have multi-links, you don't want to do an underscore number like _1, _2. That's going to goof up your multi-links. It's not going to work. It's going to crash, at least for MODSIM 8.6 and probably earlier versions. Okay, so a little side note there, but I'm just going to name it dash main. And then the other change I need to make here is I'm going to set the maximum capacity to 500,000, which is the units of acre foot per month, and that's down here. That's going to be true for all time periods, so I don't need additional rows. This is just going to be the same for every month and every year. Okay, so I'll click apply, click OK. I want to add my spill link now. This is the first link, the main link. I'm going to click on create link, and then, yeah, it looks like it's automatically naming it that way. I'm just going to call this dash spill. Now for the spill link, I'm going to allow the max flow to be exceptionally large, larger than it'll ever need to be. However, what I am going to change is this link cost. I'm going to set it to 4,000, which is a very high cost, the highest cost in my network. Click apply, click OK. All right, so my multi-link is ready to go. Click apply, click OK. Next downstream element is my consumptive demand, D1. So I'm opening up the properties box, and I'm going to be pasting in some data here. So right click and paste column. This is just some data I had saved on my Excel and I copied to my clipboard. Here is the plot. So we have demand at that consumptive demand node ranging from 40,000 acre feet up to 100,000 acre feet. And you can just consider this as historical demand. Maybe it's a combination of agricultural and urban demand. It doesn't matter what your demand is per se, but this is what I'm going to be using for this exercise. One other thing I need to do here for this demand is in the General tab, select the priority number. I'm going to change this to 90, so it's higher priority than keeping water stored in the reservoir. So that's good. I'll click Apply and OK. And then the last element we need to add data for here is our flow through demand, D2. So right click, open the properties. I'm going to start in the General tab, which is right here. And then for the priority number, I'm going to change this to 50, which is a much higher priority than 90 from D1 and 100 from Res 1. And then for the time series, I'm just going to say a constant 50,000 acre foot per month. Okay. There was one more thing I need to specify here on the flow through tab. I need to designate the next downstream non-storage node. So that is NS2. Otherwise, it won't let me save this element as a flow through demand. That's fraction is 1. That looks good. Click Apply and OK. All right, we have everything we need to run the model. So I'm going to save and then come up to MODSIM, run MODSIM. Okay. All right, looks like it ran. So I'm going to be viewing results most of the time from this reservoir, but also from the multi-link. So let's check out what we have from our reservoir first. Right click and then graph. Okay, so what we see here is a plot of the reservoir and the units are in flow here. Across the horizontal, this is our 5-year duration. And then vertically, this is the flow rate in acre foot per month. The blue line right here, let me expand this out. The blue line right here, this is the inflow. So we saw this pattern before. And then let's see here. The release is in the orange line right here. We can see the maximum of 500,000 has been reached, and it looks like it spills for this 1 month. This is the year 2023 I zoomed in on, but we can zoom out just like that. For the first few years, this looks pretty controlled, and it looks like our demand is met. We'll check that out in just a moment. Okay, before we do, I'm going to change the left vertical axis here to volume. All right, let me zoom out now. This is the reservoir volume. Okay, my original results weren't quite what I expected. I needed to change my my in-stream flow demand right here down to 20,000 acre foot per month. And the other change I made off camera was the reservoir. If you click on the targets tab, I changed this to percent of target storage. Okay, so anyway, apply. Okay, I ran the results and now see what I was expecting. So I'll click on the graph right here. And then here is the storage versus time. So we have the volume in the vertical axis here. You can see the orange line that oscillates up and down. That is our storage target. And then the blue line right here is pretty much the same thing as the storage target. The first few years, it isn't quite as high as it's expected to be. And then the volume in the reservoir on this 4th year, which is 2023, is well above the target line, which makes sense because we have a few months of very large inflows. In fact, the reservoir looks like it gets up to just above 900,000 acre feet in total volume. That also means we should not have any spill because the total storage capacity of the reservoir is 1 million acre feet. So we're pretty close, but not there. Let's take a look at that multi-link. I'm going to right click and open up the graph. Okay, so let me change this to flow. Boom. This is the flow through that multi-link. And you can see that the maximum up here is 500,000 acre feet per month. So for about 4 months, like right here in 2023, we hit the maximum, but we don't spill. All right, so next up, let's go ahead and add some conditional rules, and then that will dictate the target volume in our reservoir. So right here at volume, this orange line represents our target volume. We can modify what this target is supposed to be, what we're aiming for, based on the hydrologic state of the reservoir. So that's the flexibility that we're going to be exploring in this lesson. All right, so to add conditional rules, we're going to go to MODSIM and then click on the network settings. Let me move that over here. All right, so for this run type value, explicit targets is what we were using before. That's how in the reservoir tab, we had explicit targets each month. This time, we're going to change this to conditional rules. We have a new hydrologic state tab that opened up here. So let's go ahead and click that. This is where we create the tables that are assigned to individual reservoirs, and from those tables, it will help us decide which hydrologic state each reservoir is in. So I'm going to click on the Create Table button, and then I'll just call this H Table 1, Hydraulic Table 1, and list out the reservoirs in that table. So Res 1 is the only reservoir in our network, so that's the one we'll use. For number of states, what I'm going to say here is 4. So we're going to have a dry, a normal, a wet, and a very wet for our 4 states. Because there's 4 states, we need 3 boundary values or boundary factors here to separate those 4 different states. So this first record here is going to be between dry and normal. The second one is going to be between normal and wet. And then the third one is going to be between wet and very wet, as I'm calling it. Of course, you can define up to 7 different hydrologic states, but let's go ahead and just work with 4. So I'm doing some back of the napkin math here to try to figure out what I should use for my boundary factors. And this is not a hard science. In fact, it can change every month. But what I do know is that my reservoir is 1 million acre feet. So that'll be my W. It's the only reservoir in my set. And then R right here is the sum of, for all the reservoirs in my set, the current storage or the storage at the beginning of the time period plus that forecasted inflows. So if my peak inflows are around 800,000 acre feet and my peak storage is around 900,000 acre feet, R would be around 1.7 million acre feet and W is 1 million acre feet. So 1.7 would be the absolute max. I want to set that threshold less than 1.7 though. That's just the extreme case. So what I'm going to say is I'm going to set this to 1.2. And then between normal and wet, I'm going to set that to 0.9. And then I'll say between dry and normal will be 0.6. If I'm going a little fast, if you're not familiar with hydrologic tables, check out lesson 15 and this playlist, Reservoirs, Conditional Rules, and Hydrologic States, as well as the previous exercise, exercise 9. That's the one where I use an Excel file to track whether or not the hydrologic state of the model matches what I'm doing externally in an Excel file, and it matches up pretty well. So I'm kind of waving my hand and skipping over some of those details, kind of assuming that the viewer is familiar with this topic already. So I'm going to go ahead and click Apply and then click OK. So I have my H table defined and ready to go with those user-defined boundary factors. I'm going to click Apply and OK. Now I need to go back to my reservoir here and assign this reservoir to that hydraulic table. So here in the General tab, I now have a hydrologic table name. Now the priority right here is going to be 100. So when I assign the table, it now gives me 4 different hydrologic state priorities. And in exercise 9, that's where I change the priority based on the hydrologic state, which is going to be dry, normal, wet, and then the wettest, or maybe flood conditions, we'll call it. But for this exercise, I'm going to leave these alone. But what I will change based on the hydraulic state is the targets. So if I click on the Targets tab right here, now instead of one single column of values, which we've already input, we now have 4 columns of values. So we're going to have a different target value for each of the 4 hydrologic states for each of the time periods that we define. On my Excel file, I've copied the data I want. I'm going to go ahead and try a right click and paste time series. Okay, cool. So all those numbers popped into place. Take note that for 8.6, it seems to start in February. I haven't been able to change that, or at least no automatic way. But let's go ahead and plot these numbers here. Okay, so what we're seeing here is a plot, and we have 4 different lines representing the 4 different target reservoir volumes because we have 4 different hydrologic states, which is our dry, normal, wet, and wettest. If I click on the bar plot, okay, no change. So here is the data we're going to be seeing in our reservoir plots. Of course, we're only going to have one value actually resolve because that's the value it's going to use based on the current hydrologic state of that reservoir. So I'm going to click Apply and OK. That is all saved. Let's go ahead and run the model. I'm going to click on MODSIM, run MODSIM. Yes. Okay, that ran. Now let's check out the results here in our reservoir. So right click and graph. Okay, so here is our reservoir plot. Now what you notice is a little different here is this orange line goes up higher in the year 2023 because the hydrologic state is most likely 3. It's probably the wettest Whereas in these other years, it probably is not as wet. Actually, right here, it looks like this is the wet year. So I'm guessing the peak for these first 3 years is probably normal or maybe even dry. For this fourth year, 2023, I believe this is wet. So ID of 3 and then ID of 2. I think this is wet. Or actually, this is the wettest. This is wet. When is that? June or July? I think it's June. I'm going to take a look at the data. So if I click on data, click expand, click on this first record here, Res 1, and then scroll all the way to the far right. This is where we have the hydrologic state. So the first couple months, it's 0. That means it's dry. And then the next 1, 2, 3, 4 months or so, it says 1. That means it's normal. And then for the next 2 months after that, that would be what? July and August. That is wet. And then it looks like we're back down to normal. Because there's so much changing in this particular column of values, that may lead me to believe that my boundary factors were too closely spaced together. I used 0.6, 0.9, and 1.2, but maybe I want to make it a little bit larger, like 0.4, 0.9, and 1.3, something like that. Okay, let's scroll down to 2023. Okay, this has got to be it right here. So we have 3, 3, 3, 3, 3. That's when our inflows are the highest, and that's when our reservoir is well above the target, which is approaching the maximum capacity of the reservoir. So if I scroll over right here, actually, I'm going to go ahead and close that and then click on the storage values. From this plot here, we can get the beginning storage for each time period. And if I scroll down here, yeah, it looks like we're up to 1 million. And one advantage of using the conditional storage targets based on hydrologic state is if we click on graph again, we're probably releasing less water. So I'm going to go ahead and zoom in. It looks like we have a spike right here in January, and then another spike in March, and then a third spike in May. So it seems like every other month. Let me go ahead and check that out. So I'm going to click on flow. Yep. Let me zoom out here. Okay, I'm going to zoom back in just on 2023. The blue line is the inflow. So we have a peak inflow right here of 800,000 acre feet for one single month, which is pretty extreme and understandable why we might have some spill, because that right there, the inflow in 1 month is basically the same as 80%, more than 80% of the total capacity of the reservoir. A similar thing happened 2 months later in March, and then again in May. So it looks like because the release is 500,000, 500,000, and then almost 600,000, I believe we have spill right here in May of whatever this difference is, probably around 70 or 80,000 acre feet. Let's go ahead and check that out. So I'm going to go right click on the multi-link, click on the graph. And then, yep, sure enough, we do have a little bit of spill right here, which appears to be, 70 or 80,000 acre feet in that month of what looks like May of 2023. Yep, there it is. All right, well, that's all I had for this lesson. We created a hydrologic table. We assigned it to Reservoir 1, Res 1 right here. And then based on the hydrologic conditions, that hydrologic state was assigned, and then the specific target for that reservoir was assigned and used in the operation of the simulation.